Good morning, everyone. I'm happy to be here today for this conference, and let me take this opportunity to thank the organizers for giving an opportunity for Indian Space to present the program in this Space Expo, especially Mr. Sudhir Pai, who took the trouble to come all the way to Bangalore, meet us all, and then extend the invitation. Indian space program is basically a society-oriented program, though it has got many facets. And in this particular talk, I would like to concentrate on the societal programs that we have implemented. And due to paucity of time, I will not be able to talk on the technology part or the commercial space opportunities in India. Maybe some other opportunity I can do that. Indian space program was started way back in 1963 by Dr. Vikram Sarabhai, well-known physicist from India. And this was at a time when India was still a very poor country, trying to develop its economy. And Dr. Sarabhai understood the role that advanced science and technology can play in building the nation. He stressed the importance of using space technology to solve the real problems of man and society. Before I start, I think it is appropriate to give a glimpse of the Indian scenario, the resources that we have and the challenges that we face. India is probably 1/3 the size of US. It's the 7th biggest country in India, in the world. And we have about 1.4 million kilometer net zone area as far as agriculture is concerned. We have only 4% of the world's water resources. Our rainfall is about approximately about 35 inches long-term average. And we have fairly good forest cover. 7% of the world's biodiversity is in India. And coming to the challenges, we have our agriculture productivity compared to the world standards is low because the land holdings, the agricultural land holdings in India is very small. And most of the agriculture depends on the arrival of monsoon. It is rain-fed, and irrigation has not reached the entire agricultural area due to various reasons, because the rivers are also rain-fed. India supports approximately 16% of world's human population and 20% of the world's livestock population on merely 2.5% of the world's geographical area. About 65% of the farms, as I said earlier, depends on rain. We have unpredictable monsoons. Land degradation is one of the biggest issues, and nearly 57% of the land is degraded in one way or the other. And because irrigation is not reaching all places, the groundwater exploitation is very high, and there is a concerted effort to see how this problem can be solved. Declining per capita availability of water, overexploitation of groundwater for irrigation are more important issues that need to be tackled. Coming to the disaster scenario and the challenges therein, India has been traditionally vulnerable to natural disasters on account of its geoclimatic conditions. Floods, droughts, cyclones, earthquakes, and landslide have been a recurrent phenomena. We have earthquakes and landslides in the Himalayan region in the north, as well as in the mountainous Western Ghats in the southwest. Cyclones are a recurring phenomena in the east coast of India, which is a very large area. We have about 7,500 kilometer long coastline, out of which 5,700 is the east coast. And the east coast is also susceptible to tsunamis, and 40% of the area is prone to drought, and about 40 million hectares are prone to floods. Andaman and Nicobar Islands on the Each part of the west coast are vulnerable to, again, tsunami. And I will just, in the coming slides, touch upon some of the space-based activities that we have done to address these challenges. Indian space had a humble beginning in the 1960s with very small remote sensing program, which was basically an aerial remote sensing program, which addressed the coconut root wilt disease in the southwestern state of India called Kerala. So this gave the scientists a good idea about what space can do in assessing the area and the spread of agricultural diseases. And this was a fillip to the program, and from there on the remote sensing program took a great leap into satellite-based remote sensing. Communication started in 1975 with an experiment which spanned across hundreds of villages, where an American satellite was actually used to beam societal programs to villages. This was well received all over India, and then this convinced the government also to invest in the communication program that is well established today. And sounding rockets program was started then, and it is continuing even today with the probing of the upper atmosphere. And these activities in the early stages led to the development of the larger programs in the application areas that is mentioned here, in agriculture, in water resources, forestry, urban planning, rural development, ocean resources, and in communication we have DTH-based communication, very popular in India. And navigation, we have our own navigation system. I will touch upon that later. And we have a comprehensive disaster management program. India is an agrarian country, basically. Agriculture is the most important sector of Indian economy and accounts for 18% of India's GDP and provides employment to 50% of people. India's population is bound to cross 1.6 billion by 2050, which will demand doubling of our food production to ensure food security. There is an urgent need for increasing agriculture productivity without degrading the environment. This necessitates focus on development of rain-fed areas, degraded lands, analysis of cropping systems, proper monitoring and management of agricultural practices, assessing the impact of droughts and floods and so on. And this is where the satellites came in. Reliable information on crop acreages, timely forecasts and estimates of production and yields are important for trade as well as various downstream and upstream activities, as you know. Remote sensing technology using ResourceSat and RISAT, the radar imaging satellite of India, is being effectively used for crop acreage and production yield estimation of 8 crops. These 8 crops are shown down below there. And research is going on to increase that number of crops to 25. And staying again in agriculture, we have crop intensification, crop diversification, identifying wasteland to increase the area under agriculture, crop health, etc. This is also done using these 2 satellites, the ResourceSat and the RISAT. And one important application I would like to mention here is the soil health card that the government of India has implemented using space technology, which is given to the farmers. So it is a card with a QR code, which once scanned, it will access the backend database, the satellite database that is created by ISRO, which is also having the in situ information plugged in, and also the expertise of agricultural scientists. And the farmer will be immediately able to know what are all the good crops that he can sow in his land. And this is continuously updated. And you can see on the right side bottom, the agriculture production that has gone up. This trend has to be increased in the other crops also for ensuring food security in the future. Coming to water resources. As you know, water is a crucial resource for agriculture. In India, most of the small farms or most of the full farmers are living in arid and semi-arid regions that does not have proper irrigation facilities, and they need to know the availability of water. And picture here shows the surface water body layers at 15-day intervals. This one, created using resource data for planning purposes. Every 15 days, you will know what is the water level in various water bodies, surface water bodies, all over India. This is done for the complete Indian region. About 60% of total food grain production comes from irrigated area in India, which is about 40% of the net zone area. Remote sensing technology is also being used for water resource assessment, irrigation scheduling, reservoir sedimentation, snow melting. These are some of the applications that has been implemented using space technology. Staying on water resources, the high-resolution Cartosat data has been used to map the irrigation infrastructure and monitor its progress. This is another activity. Cartosat is a high-resolution satellite. We have Cartosat 1 and Cartosat 2 series operational in India. Cartosat 3 is about to come, which will give us less than 50 centimeter resolution. And this is used primarily to see that the irrigation infrastructure, the canals and so on, what is the progress that has been achieved. And India is a big country, so sitting in Delhi, you can see the gaps and then what needs to be done to complete a particular program. And this is this project has been carried out in 2 phases for 103 selected command areas, covering an area of about 63,000 square kilometers. And this is a clear example of time-stamping of infrastructure created, gap analysis, and compliance monitoring, which has been implemented using satellite technology in India. Again, I would like to inform this August gathering that resource-based database applications has been used to prepare groundwater prospect for hydrogeomorphological maps at 1:50,000 scale for the entire India. This is available in a portal called the Bhuvan portal, which is similar to Google Earth, but then in that all thematic layers are there. So anybody wanting to know the information about the groundwater can go to that theme and then get the information that he needs. And these maps help to narrow down the search area to identify the potential groundwater sources, as well as to identify the recharge sites. So this is an important activity that has been implemented. And from 1987 onwards, India is bringing out state forest report based on resource data. This is, you can see here, the forest cover, how it is increasing. It has reached 24.4% now, and India is ranked 10th in the world, even though India accounts for only 2.4% of the world's surface area and needs to sustain the requirements of 17% of human and 18% livestock population in the world. So this was made possible because of constant monitoring, using satellites, and then informing the various departments about the degradations or the need to plant more trees and vegetation in forested areas. India is placed 8th in the list of top 10 nations reporting greatest annual gain in forest area. So this is one statistics that was made possible because of the involvement of satellite technology. Coming to environment, wetlands are areas of critical ecological significance, as you know. India has a variety of wetland systems ranging from high altitude cold desert wetlands to hot and humid wetlands in coastal zones. The wetlands are under threat due to developmental activities and population pressure, and their preservation and conservation calls for long-term planning. Data from ResourceSat series has been used to map the wetlands in the country, and national and state level atlases have been brought out to improve our understanding of the dynamics and distribution of wetlands and their status, as well as in planning conservation measures. Coming to urban and infrastructure planning, remote sensing has a big role to play here. We are using, again, the high-resolution Cartosat 2 series satellites for this activity, which has got a resolution of sub-meter resolution, maybe about 0.6 meters. The number of towns and cities in India has increased from 5,161 in 2001 to 7,935 in 2011. Today, it may be even much bigger. Currently, about 53 cities have more than 1 million population, and about 412 cities have 100,000 population. And there is a need to prepare master developmental plan to meet the requirements of these cities. And under the Government of India's Amrit program, about 500 cities are being covered with the aim of providing civic amenities like water supply, sewerage, urban transports, parks, etc. Under this project, using satellite technology, 5 base layers and urban land use layers at 4K are being prepared using Cartosat 2 series very high resolution or VHR data. Under the Smart Cities mission, another flagship mission of Government of India, 99 cities have been identified for development with a total investment of approximately $28 billion. This also will use data from the Cartosat series satellites, and the strategic components of the small cities will be using this Cartosat data-based plans for implementing the various action plans for the development of the cities. Another now important application is in archaeology. This is using Cartosat 2 series high resolution data. This is for archaeological site management. India, as you may be knowing, is culturally very rich and diverse with a long history. This richness and history is visible in historical architectures and monuments and are of national importance. In the first phase, an inventory of about 3,000 heritage sites has been prepared, and demarcation of zones has been done as protected zone. You can see the inside circle is a protected zone. Then the prohibited, this is a protected zone, this is a prohibited zone. And the regulated zone, the outer circle is the regulated zone. This geodatabase has been used to regulate building permissions online. So this is now implemented and active. Coming to ocean, India has this satellite called OceanSat, where the ocean color monitor sensor is available, and it gives the data for monitoring the ocean and its resources. In India, more than 7 million people living along the 7,500 kilometer coastline. India has got a long coastline. So the west coast, you can see, the east coast is here. They are dependent on fishing for their livelihood, and ISRO, along with Ministry of Earth Sciences, are providing OceanSat satellite-based potential fishing zone advisories in local languages to the fishing community. And what this does is, this app is available for the fisherman, and or he can go to the nearest resource center where they will be told about the availability of fish schools in the ocean and the location of those schools, and then they can navigate towards those areas and then have their catch. Phytoplankton and sea surface temperatures are derived from OceanSat and also the Indian national satellites INSATs. While chlorophyll acts as the food for fishes, the sea surface temperature gives conducive thermal regimes. With this, we are able to predict where they can go to have their catch. This operational application has resulted in reduced time and effort in fishing and increased fish catch. The feedback received from various fishermen's associations and other agencies indicate that fish catch has been doubled, with reduction in search time by about 60% and fuel cost by about 30%. So this has been a very, very successful program that has been implemented using satellite technology in India for the fishermen that are living along the coastlines. Coming to weather, we have prediction of weather in tropical regions like India is a major challenge due to the complex and dynamic nature of the weather system. We have several satellites, important 2 satellites that are working for predicting the weather is the INSAT 3D and INSAT 3D-R. The satellite images on cloud cover and various parameters such as winds, rainfall, sea surface temperature, etc. facilitate rainfall estimation, weather forecasting, genesis of cyclones, and their track prediction. As I told earlier, the East Coast is susceptible to cyclones. Even a couple of weeks back, we had a cyclone hitting the southeastern coast of India. Currently with INSAT 3D, INSAT 3D-R, they are in operation. Indian Meteorological Department or IMD is in advantageous position, providing forecast once in 15 minutes. Coming to disaster scenario, I have briefly touched upon the disaster scenario in India earlier. India has established the Decision Support Center to monitor the disasters, built a comprehensive spatial database based on INSAT 3D, 3DR, and also SCATSAT, another satellite that we have to measure the wind vectors for emergency management. Space inputs are the first data available to monitor the disasters, as you may be aware, and these are provided to the national and state disaster monitoring agencies. We also provide support to international disasters through the UN charters, hazard zonation maps for flood and landslide, and also agricultural drought maps are prepared using satellite data regularly. These are used as inputs for developmental planning. We also have the early warning systems for flood and cyclones. They are in place, and these are working well. We also measure the snow melt because the rivers which are originating from the Himalayas are susceptible for flood due to the snow melting. So this is also predicted well. Today we are also in a position to predict the formation of cyclone even before the depression turns into a cyclone. We are also in a position to give 24 to 96 hour forecasts for the cyclone. We have improved upon our accuracies, and with 24-hour forecast, the land prediction accuracy is about plus or minus 40 kilometers, and landfall time is about an hour. So that kind of an accuracy is achieved. Some of you may be aware of the unprecedented floods in southern Indian state of Kerala a few months back, where Resourcesat and Cartosat data that is shown here, this Cartosat data were used to predict or to assess the situation. And our scatterometer data and meteorological data were used to provide forecast during the cyclone. The availability of 15-minute data from INSAT 3D and 3DR satellites is expected to increase the efficiency of track and intensity prediction of cyclones greatly. Coming to satellite communication, you all know the power of communication, and currently we have about 15 communication satellites above India, serving the various communication needs. India has got a very strong DTH user base. There is also cable, but unlike America, probably the DTH is the predominant video carrier in India. And of course, the cable services spearheaded by Reliance Jio is coming up now, and that is probably expected to make some dent in the market of DTH companies. But the commercial aspect of that, maybe I will touch upon in some other time. Some interesting developments are happening in that front as well. The satellite systems, the communication satellite systems is also used to transmit the all-weather station and rain gauge station data to respective centers. Search and rescue services are also provided using these communication satellites during disasters. Coming to satellite navigation, we have, I told you earlier that we have our regional navigation system, regional GPS over India, which covers the entire Indian region. We also have implemented the SBAS system, that is in partnership with the Airports Authority of India. The GPS-aided geo-augmented navigation is an SBAS system for civil aviation sector. So that is, the space sector is ready, the ground sector is under implementation. The navigation with Indian constellation, or IRNSS, what we call the Indian regional system, the space segment is fully commissioned. There are 8 satellites now in that constellation, and the ground systems and applications are under development. And two very important applications in that I would like to mention these two applications. One is the warning system for unmanned level crossing. India has got more than 5,000 unmanned level crossing, and we keep hearing about the accidents that are happening in this unmanned level crossing, which is very bad. And after the implementation of the Indian regional GPS system, we have developed the technology to predict the arrival of a train at all these stations. This technology is proven and handed over to Indian Railways for implementation. This is currently under implementation. The second important application, what I am mentioning here, is the application which will assist the Indian fishermen. India has got hostile neighbors, and the fishermen, if they wander across the international borders, they will be caught, and there are hundreds of fishermen in other jails of other countries. So to stop that, we have developed an app and a device, a Navic-based device, which will alert the fishermen about the international borders that they are reaching and help them to stay inside. And this app also will help the fishermen to get information on the weather, on the sea roughness, etc., which will help them to stay in the sea and avoid danger. So these are two very important applications under implementation in India. And staying in the societal applications of space, we have two important applications there: tele-education and telemedicine, that you may be aware of these two applications. Mahatma Gandhi had said that the soul of India lives in its villages, and nearly 60% of Indian population lives in about 600,000 villages in India. In spite of various efforts to improve the living standards, around half of our village still have subnormal socioeconomic conditions. Many villages does not have basic amenities and services, especially those related to education and health. So tele-education enables formal education by connecting primary schools that you may be aware, primary schools and colleges with quality teaching. Currently we have about 50,000 virtual classrooms using satellites for connectivity. And telemedicine, likewise, has got enabling healthcare and related training in the rural areas. Currently 382 hospitals, 307 rural hospitals, and 59 specialty hospitals. They are connected to this network, benefiting about 1 million people, but there is a lot more work to be done in that front, actually. Envisioning the potential space-based inputs for countries' development, India has conceived National Resource Management System, or NNRMS, way back in 1985. It is an institutional mechanism, just for your information, wherein all stakeholders are involved so that the data can be effectively used for applications in diversified areas. During the last 4 years, we are having one-to-one interactions with nearly 60 departments of the government of India, so that space inputs can be used in their planning, monitoring, and decision. The focus is to involve all the departments, the person below doing the actual work, to teach them about the space technology and then enable them to implement it on ground. So this activity is going on now. It is going well. And coming to our the space assets, we have about 15 operational communication satellites. We have about 18 remote sensing satellites, including 3 in the geostationary orbit, the INSAT 3D, INSAT 3DR, and Kalpana. These are the 3 satellites that are in the geostationary orbit. And we have about 8 navigation satellites for the regional GPS system. So coming to Vision 2030, with nearly 6 decades of Indian space program, we have matured to build communication, Earth observation, and navigation satellites, and also launch vehicles to launch these satellites in different orbits. What you see here is the current space assets of India, which are being used in various space-based applications. Our vision is to use space technology to address food, water, energy, health, shelter, and infrastructure security towards sustainable development, disaster risk reduction, and improved governance. I hope this clarifies why we are in space and what we are actually doing. Let us join hands to harness space technology for solving the problems of mankind. Thank you.